Let's review for the exam. Question 1. I want to find A complement union B and then intersect that with C. So the first step is to find A complement, and recall A complement is everything that is not in A. So I need to look at our universe and take out everything that is not A. So A complement would be everything that's not A, and that's 1, 3, 5, 7, 8, 9, 10, 11, 12, 13, and 14. So that's A complement. I'm going to union that with set B. Set B is 0, 2, 4, 6, 8, and 10. And now after that, we're going to have to intersect that with set C. And set C is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to intersect that with this set. Now, let's do the union first, since that's inside the parentheses. Recall the union is in one or the other or both. So I'm going to essentially list all of the elements from these two sets here, A complement union B, without any repeats. This is going to give me the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So again, A complement union B is everything in this set, or both. And I believe we have all of the elements from both of the sets. And now we're going to intersect that with this set here, set C. Now the intersection is what's in both. So let's find all of the overlaps. They both have a 0. They both have a 1, a 2, a 3, 4, 5, 6, 7, 8, 9, 10. They both have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means my intersection is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the solution for question 1. Question number 2. Let's evaluate the following expression. Recall the orders of operation, PEMDAS. So let's look for any grouping symbols. I have a set of parentheses here, 9 minus 8. So let's perform that operation first. 9 minus 8 is equal to 1. And then I'll copy everything else exactly as it is. We will look for more parentheses, and in this case we don't have any more parentheses. These are in fact multiplications. This is a multiplication and this is an exponent. So we'll move on to the exponents. We have a 2 squared, so we'll do that next. 2 squared is positive 4, so we'll replace this with 4. Then we have multiplications or division from left to right, and in this case we have 2 multiplications, so we'll do the first one on the left. Negative 4 times 1 is negative 4. And negative 7 times 4, that gives us negative 28. We'll simplify this. Negative 4 minus 28 is negative 32. So make sure you follow the orders of operations, going from left to right when you're doing multiplication or division. Question number 3, let's simplify the expression. And The first thing I want to do with these exponents is to distribute that 2 to the 8 and to the invisible exponent of the 4, which is a 1. We'll also distribute that 2 to the 5 and to the 7. Remember, this 5 has an invisible exponent of 1. So this is equivalent to 4 squared, because 1 times 2 is 2. And this is x to the 16th, because it's 2 times 8. We have in the denominator 5 raised to the 2nd. Again, 1 times 2 gives us 2. 7 times 2 gives me 14. And now we'll have to simplify this. We know 4 squared is 16. We know 5 squared is 25. And we'll double check to make sure there's no common factors. 16 and 25 does not have a common factor, and we cannot reduce this expression. So this is our solution for question 3. Question number 4, find the sum or difference. Always try to get rid of these parentheses if possible first. In the first case, there's nothing to distribute, so I'll just remove the parentheses for the trinomial here. For the second term in the middle, notice there's a negative in the front, so I'll have to distribute that negative throughout this middle term. So we have negative 9m cubed minus 2m squared minus 5m. Again, we're distributing this negative. You can pretend that's a negative 1 multiplied to these 3 terms here in the middle. Now for this addition, we're not distributing anything, so we can remove the parentheses. Now let's collect like terms. I always start with the highest power first. I have 7m to the 4th. And then we'll look for the cubic terms. We have negative 9m cubed next. And now the squared terms. We have 3 of them. Negative 5m squared, negative 2m squared, and m squared. So we'll add negative 5 plus negative 2 plus 1, there's an invisible 1 here, and that's going to give us negative 6m squared. I have m, negative 5m, and negative m. All together, that's negative 6m. And that's all we have to do for question number 4. Question number 5, we'll use the distributive property to find the product. So let's multiply the 3y times every term to the right. We'll do this slow. 3y times negative 5y squared is negative 15y cubed. 3y times 7y is 21y squared. 3y times 1 is 3y. Now we'll multiply negative 4 times each of the terms on the right. Negative 4 times negative 5y squared is positive 20y squared. Negative 4 times 7y is negative 28y. Negative 4 times positive 1 is negative 4. Now we can collect like terms. We have negative 15y cubed by itself. And now I could add the squared terms. We have 21 plus 20y squared. That's going to give us 41y squared. And now we can do 3y and negative 28y. That together is negative 25y. And I'll bring down this negative 4. Again, notice how I underline each of the terms, so I know I'm not forgetting any of the terms. And this is our solution, negative 15y cubed plus 41y squared minus 25y minus 4. Question number 6, this is polynomial long division. So we want to make sure it's in descending orders of power. We have a 3, 2, 1, and a power of 0. We have a power of 1 and a power of 0. So this is in the correct descending orders of power. We'll put the 2m plus 3 into the front. And then we'll put the dividend as 8m cubed plus 14m squared minus 7m plus 1. Now we'll multiply. 2m times what gives us 8m cubed? I know that's going to be a 4. That's the only way to give me an 8. And this has to be an m squared because m squared times m gives me the m cubed. So we know this is correct. And we'll multiply this to our divisor. 4m squared times 2m is 8m cubed. 4m squared times 3 is 12m squared. Now we'll distribute a negative because we need to subtract. This is going to give me a negative 8m cubed. And again, this is going to be distributed. This gives me a negative 12m squared. Let's add these up. We have this cancels out. 14m squared minus 12m squared produces 2m squared. Now I can bring down the negative 7m, and I could also bring down the positive 1. And we'll repeat the process. 2m times what gives us 2m squared? That's going to be m. So 2m times m gives us 2m squared. Then I'll have to distribute this to our divisor again. 2m times m is 2m squared. 2m times 3 is 3m. And then I'm going to subtract. Don't forget to distribute the negative. This is going to give us a negative 2m squared. And this is going to give us a negative 3m. We'll add this up. This produces a negative 10m. And again, we'll drop down that plus 1. Now we'll repeat the process. 2m times what gives us negative 10m? Well, that's negative 5. Then we'll multiply the negative 5 times our divisor. Negative 5 times 2m is negative 10m. Negative 5 times 3 is negative 15. Let's distribute a negative again throughout this expression. And that changes to all of these to a plus. And when we add this, we get a 16. This one cancels out. Now we can't continue this process any further. This is our remainder. This is our remainder. So now we can write down our answer. 4m squared plus m minus 5 plus 16 over 2m plus 3. This is our solution. We have to have the quotient plus the remainder here on the right. For question number 7, we're going to factor the trinomial if possible. Notice that there are no GCF terms in this question. I do not have anything that I can take out from all three. So we'll go on to the next step, and that's to look at the number of terms. If you look at the number of terms, there's 3. So that means I'm going to use the AC method or the diamond method. In this case, since there's a leading coefficient, I'm going to use the AC method. We're going to multiply the 6 times the 4. That gives me 24. And then put the negative 11 on the bottom. Let's find two numbers that multiply to get 24. But they have to add up to get negative 11. So the two numbers are negative 3 and negative 8. That's the only way to multiply to get positive 24 and add up to get negative 11. So I'm going to rewrite this now as 6r squared minus 3r minus 8r plus 4. Now what we did is we just rewrote negative 11 as negative 3r minus 8r. So we split the middle into these two terms. Now the reason we did that is notice that we have 4 terms now. And to do 4 terms, we're going to use factor by grouping. So let's look at the first pair. They contain a common factor of 3 and r. So let's take out 3r. That leaves me 2r minus 1 left. And for the second term, they have a common factor of 4. Now if I were to take out a 4, I would not get 2r minus 1 left over. So let's take out a negative 4. And that will leave 2r minus 1 left over. The reason we need a negative 4 is these two have to be the same. If they're not the same, then we can't factor it. But since they're the same, we know we did it right. This gives me 2r minus 1. I'm going to take this to the front. And what's left is 3r minus 4. And this is our factored trinomial. Question number 8, we want to factor the trinomial if possible. Again, I want to look for the GCF. Is there a GCF? This is a 12, this is a 10, this is a 12. So there's a common factor of 2 in all of the terms, and they also contain a v. So we have the GCF is 2v, and so I'll start by taking out 2v to the front of each of the terms. So we have 2v, that gives me 6v squared left over. That's the only way to get 12 back and a v cubed. How do I get a 10 back? I need a 5, and we need a v squared, so we'll add a v here. To get negative 12 back, we need a negative 6, and we don't need a v because v will be here. Now if you're not sure, well, distribute. Distribute this out, and you should get the original trinomial back. But in this case, we know we did it right because we do multiply to get the original back. Now since there's only 3 terms left here, I can try to factor this part of it. Let's use the AC method. 6 times 6 is negative 36, and we'll put the 5 on the bottom. Our 9 and 4, that will multiply to give us a 36, but I need a negative 36, so let's make this a negative 4. And the reason I chose this to be a negative 4 is we have to add up to positive 5. So these two numbers are correct. 9 times negative 4 does give us negative 36, and it does add up to get 5. So let's split the middle again, just like in question number 7. This is 6v squared. We'll rewrite 5v as 9v minus 4v minus 6. Now since the terms have become a 4-term polynomial, we can use factor by grouping. Let's take out a 3v from both of these. I get 2v plus 3 left over. And here I'll take out a negative 2, and that gives me a 2v plus 3 again left over. Now this has to be the same, so make sure you are taking out a positive or a negative to make these two the same. So in order to factor this, we have 2v in the front, and then since we took out 2v plus 3, that leaves us 3v minus 2 left. And this is our factored polynomial. Question number 9, this has 2 terms in it, so I know we're going to use the difference of cubes formula. X cubed minus y cubed is equivalent to x minus y times x squared plus 2xy plus y squared. So this is the formula for the difference of cubes. And so what I like to do is figure out what our x's is and what our y's are. So let's figure out what goes inside. I'll do a blank parentheses cubed minus another blank parentheses cubed. So what cubed gives us 125? That's 5. And we'll need an x to get the x cubed. What cube gives us negative 64? So I know this is going to have to be a 4. 4 cubed gives us that 64 back. So this tells me what my x is. The x is the 5x. The y is the 4. So we'll just plug everything into the formula and we will get our solution. According to the formula, we'll have x minus y first. So that's 5x minus 4. Then we'll do x squared. So this part is going to be squared. I like to put parentheses around it. Then we're going to multiply by 2 times 5x times 4. Then we're going to add the y squared part, and that's going to be 4 squared. We're almost done. We just got to simplify. This gives us 25x squared. 2 times 5 times 4, that is 40. And then we have an x, so that's 40x. And 4 squared is 16. And we just finished the problem using the difference of cubes formula. Question number 10, let's factor the polynomial. Notice that this is a power of 4. We're used to polynomials of this form, powers of 2, so we're going to have to convert this. I'm going to rewrite this as a power of 2. So let's say 6t squared, but I need a 2 here. That's the only way to get the 4 back. So if you look at it now, this is a power of 2 just like we want here. So we'll have to make a u substitution. So let's let u be equal to t squared, and that's going to transform these into something I know how to do. I can replace all of the t squareds with the letter u. So this is 6u squared minus 17u minus 14. Now this is going to be the AC method. We have 6 times negative 14. That gives me negative 84. And we'll have negative 17 on the bottom. So let's figure out the two numbers that multiply to get negative 84 but add up to negative 17. And the two numbers are 4 and 21. And so which one has to be negative? It has to be negative 21 because that's the only way to add up to get negative 17. So let's rewrite this as 6u squared plus 4u minus 21u minus 14. Again, we just split the middle. We're using the AC method here. And now we can do factor by grouping. The first pair has a 2u in common, so let's extract that to the front. That leaves us 3u plus 2 left over. And now I'll take out a negative 7, and that leaves us 3u plus 2 left over. Again, be careful when you factor the second part. You want to make sure these two are the same, and we know we did it right. This factors as 3u plus 2 times 2u minus 7. Now don't stop here. We are not factoring in terms of u. We're factoring in terms of t. So let's replace all of the u's with t squared back, and that will give us our final solution. This is 3t squared plus 2 times 2t squared minus 7. And this is our final solution for this example. Question number 11. We want to write the rational expression in lowest terms. So we'll have to factor each one of these and see what divides out. Notice we have a 3-term polynomial on the top and on the bottom, so let's factor it. Since there is a 1 in front of each one of these, we're going to use the diamond method. The diamond method is very similar to the AC method, but we don't need to split the middle. Once we find the numbers, we just factor it. So what two numbers multiplies to get 15 but add up to -8? That's -3 and -5. And the two numbers that multiply to get -40 but add up to get 3 are +8 and -5. So make sure you're careful with the sign. 8 plus -5 gives us 3, and 8 times -5 does give us -40. So the nice thing about the diamond method is we just write down x minus 3, x minus 5, because of these numbers here, and for the bottom we have x plus 8 and x minus 5, again from these numbers. I have the x minus 5 and the x minus 5, they divide out, they become 1s, because the same number divided by the same number is 1. And so our solution is x minus 3 divided by x plus 8. This is our simplified rational expression. Question number 12. We're going to recall that if you are dividing two fractions, you got to keep the first one the same, change the middle one to multiplication, and then flip the second term. So that's what we're going to do first. We're going to rewrite this as 35m plus 315 over 7m minus 42. Flip the second term, and that's going to give us m squared minus 3m minus 18 over m squared minus 81. Let's factor out the GCF. I noticed that the GCF of these is 35. So let's factor out a 35 to the front. That gives me m plus 9. And on the bottom left, this is also a GCF of 7. So let's take out a 7. That gives me m minus 6. We're multiplying by. Now this is a trinomial. We'll use the diamond method since the leading coefficient is 1. That's -18 and -3. The two numbers are -6 and +3. That multiplies to get -18 and adds up to get -3. So that means this factor here factors as m minus 6 times m plus 3. Again, we use the diamond method because the leading coefficient is 1. You could look at m squared minus 81 as m squared minus 9 squared, and this is the difference of squares. Recall x squared minus y squared equals x plus y times x minus y. So I can rewrite this expression as m plus 9 times m minus 9. And let's see what divides out. We have the m plus 9 divides out with the m plus 9. We have the m minus 6 divides out with the m minus 6. We have 35 and 7 reduced, so that reduces to a 1, that reduces to a 5. We'll multiply everything straight across. This gives me a 5, m plus 3 on the top, and on the bottom we have just an m minus 9. And this is the simplified solution for this question. Question number 13. We're going to have to distribute the exponents. So we have the -3 is going to that invisible 1 for the 11 and the invisible 1 for the w. We have the -2 is going to the invisible 1 for the 11 and the 2 for the w. This 2 goes to the 3, the -3, and this 2 goes to this -2. So let's simplify this. This is 11 raised to the -3, w to the -3, 11 raised to the negative 2 and w raised to the negative 4. On the bottom we have 11 raised to the negative 6 and w raised to the negative 4. So let's simplify the numerator. We have 11 to the negative 3 and 11 to the negative 2. That is 11 to the negative 5. We're going to add the exponents together, and we have w to the negative 7. Again, we're adding negative 3 and negative 4 together. On the bottom, we have 11 to the negative 6 and w to the negative 4. Now from here, we're going to have to subtract the exponents because we're dividing. So this becomes 11 to the negative 5 minus a negative 6. And w to the negative 7 minus a negative 4. So these double negatives become positives. This is 11 minus 5 plus 6. And this is negative 7 plus 4. This simplifies to 11 to the 1, or just 11, and w to the negative 3. Now this is not acceptable. We want to make sure the negative exponents are shifted up or down. In this case, we'll shift the w to the bottom. This is our solution, 11 over w cubed. Question number 4. Let's start by breaking up the 396 using our factor tree. I know 396 is the same as 3 times 132. And 132 is 11 times 12. 12 is 2 times 6. And 6 is 2 times 3. So we can rewrite this as 2 times 2 times 3 times 3 times 11. Again, the numbers are from here. 2 times 2 times 3 times 3 times 11. And we have x to the 6th, y to the 15th. Now we're looking for groups of 2 because this has an divisible index of 2. So I know the cube root of these two parts is 2 times 6 in the front. We have an 11 left on the inside from here. Now I'm going to take the 6 and the 15 and we'll divide it by 2. 6 divided by 2 is 3, remainder 0. 15 divided by 2 is 7, remainder 1. And so I know there's x cubed in the front because of this 3, y to the 7th because of that 7, and what's left inside is 1y. There's no x left inside because the remainder is 0. And now we'll simplify this as 12 because 2 times 6 is 12. And we'll copy the rest. So this is our solution for question number 14. 12x cubed y to the 7th times the square root of 11y. Question number 15, we'll use the foiling technique. So we'll multiply 2 root 3 times 3 root 2. 2 times 3, that gives us 6. And root 3 times root 2 is root 6. 2 times negative 1 gives us negative 2. Root 3 times root 3 is root 9. 1 times 3 gives me 3. Root 2 times root 2 is root 4. Root 2 times root 3 is negative root 6. And then we'll try to simplify this. We know this is 6 root 6, and this is 1 root 6. So adding those up together, negative 1 plus 6 is 5 root 6. I can simplify the square root of 9, that's just 3. The square root of 4, that's equal to 2. And so now we have negative 2 times 3 and 3 times 2. Let's simplify that. That gives me negative 6, and this gives me positive 6. The 6 and the negative 6 cancels out, and that means our solution is 5 root 6. Question number 16, we want to rationalize the denominator. In this case, notice how the bottom has 2 terms in it, so we'll use the conjugate. Recall the conjugate is the same thing in the denominator except we have a different sign. This is a plus, so I'll use a minus. So it's root 13 minus root 10. For the top, we'll have to distribute. Root 10 times root 13 is root 130. Root 10 times root 10 is root 100. For the bottom, we don't have to FOIL. We can use the shortcut. Recall the difference of squareds. X squared minus y squared is x plus y times x minus y. So I can use the difference of squares to calculate this very quickly. So this gives me square root of 13 squared minus the square root of 10 squared. The square root of 130 can't seem to simplify that, so we'll copy it. The square root of 100 is 10, and the square root of 13 squared, that's 13. The square root of 10 squared is 10. So we'll just have to simplify the bottom now. And so the top is 130, the square root of 130 minus 10 over 3. And this is our simplified expression. It is now rationalized. Question number 17, we want to solve the equation. First, we'll have to distribute the 5. This gives me 25x plus 45, and then I'll distribute this negative. This is 13 minus x minus 7. Let's collect like terms. I can't add anything on the left, so we'll copy it down. Let's try to line up our equal signs if possible. 13 minus 7, that is giving us 6, and we have 6 minus x on the right. Let's add x to both sides. That gives me 26x plus 45 equals 6. Let's subtract the 45 to both sides now. That gives me 26x equals negative 39. And now I can divide both sides by 26. X is equal to negative 39 over 26. Let's see if there's a common factor. There's a common factor of 13. So we have x equals negative 3 over 2. This is our solution. We reduce the top and the bottom by 13. Question number 18. Solve for the given formula. Question number 18. Solve the given formula for the indicated variable. Assume that the denominator is not 0 if the variables appear in the denominator. So for this question, we want to solve for h. That means get the h by itself. So let's move everything that doesn't contain an h to the other side. So I'm going to subtract 4lw to both sides. So this is s minus 4lw equals 4wh plus 5hl. Now h's are on one side and everything else is on the left. I can factor out the h from both of these terms. So we'll take out the h, and that leaves us 4w plus 5l. If you're not sure, distribute it, and you should get the original term back. On the left, I didn't do anything. We'll just copy it as s minus 4lw. We have one more step to go. We want to solve for h. So how do we get rid of 4w plus 5l? We're going to divide both sides by 4w plus 5l. And that means h is equal to this expression, s minus 4lw over 4w plus 5l. And we have solved for h.